Thank you all guys for being here. It's the last day and the last time slot of the talk. Looks like pretty tough. Today we're gonna talk about a few command and control tools. Let me have a quick intro of myself. My name is Hubert Lin, and I've been doing cybersecurity for almost 20 years, starting from the defense side, primarily on the IPS signature development, before I transitioned into a more offensive side, doing red teaming. And eventually I moved to a more research-oriented job role here at Netskope. So other than talk about the C2 tools, we'll be discussing some of the features that we're interested in. And we'll also talk about the flexibility of their C2 configuration to see how flexible they are. And if we've And if there's some static patterns we could observe, we could also see the possibility if we could detect them with IPS signatures. And on the contrary, we'll try to evade them if we're on the offensive side. And finally, we'll sum in all those tools up and rate them with from different aspects to have a comparison table. And in the end, we'll have some takeaway actions from what you've learned today. Yeah. Since there's so little time covering all those tools, there's definitely something we're gonna skip, especially those including software installation as well as configuration and setup. And we're also not covering the endpoint detections here. So you think 8 tools is a lot? Well, the bad news for you, because there's an open public Google Sheet called the C2 Matrix, which is created by George Ochlis. There's around 115 other C2 tools here in these sheets. And some of the tools we'll be covering here are not even in the matrix. I hope that our coverage is enough to provide, to make you have a rough idea of how things works. Quick questions. How many of you have ever tried or used any of the C2 tools in a good way, maybe? Okay. Good to know, thanks. I think we all have some good reasons to cover or to use those C2 tools. For me, other than obtaining some fun from the hands-on exercises, I also used to inspect the traffic it generates, as well as understand how it works, especially its network behaviors. Since I used to be an IPS guy. So let's get started with the first one. And no doubt, the first one will be Metasploit. Metasploit is a long-standing pen testing open source tool used by pen testers as well as in some use case in cybersecurity training. Since its major purpose is more like an exploitation framework that covering around 2,500 exploits targeting vulnerable software and operating systems, which makes it a quite powerful tool that can be used during the early stage of the attack. We call it the initial access. By leveraging the powerful exploitation targeting maybe some vulnerable server, we could further infiltrate that server to RCE and then make that vulnerable server run the payload we would like to run. If we forget about the exploitation part, the tool itself provides a tool called the Unmasked Venom, which can be used to further create payloads that can be used to run on the victim machine. And the best part of this tool is it supports more than 30 different executable binary files, which make it highly portable if you have different targets other than the major operating systems. In the following walkthrough, we'll all show some screenshots of the callbacks from the victim machines. They all look pretty similar, other than the basic information. From here, we can see what the attacker can see. And once victim callback by executing the C2 agent, the attackers can further control the victim machine through this text-based user interface. We call it the Meterpreter in the context of Metasploit. In the Meterpreter, it's actually a post-exploitation tool that allows the attackers or the operators to conduct activities toward the victim machine. Yeah. Hence we call it command and control. For the rest of the tools, they all have similar features such as privilege escalation, data exfiltration, etc. If you're seeking a more user-friendly interface, Metasploit also provide a GUI tool called the Armitage, which might make your life easier if you have some collaboration effort with the team members. In short, Metasploit, since Metasploit's been out there for quite a long time, but its purpose is not on the command and control at early stage. So from the flexibility point of its configuration, it lacks a few very basic settings like the sleep time or the jitter that can be further tuned the frequency the client callback. But for me, it's still a highly recommended tool for those beginners that have highly interested in the offensive side. With this tool, we can practice either the initial access stage by leveraging the high variety of the exploits. And once we get the victim machine compromised, we can further use the Meterpreter to have a deeper control of the victim system. Next, Merlin, which is developed by Mr. Russell Ventile in Go language. And one of the best thing I like is it supports some modern protocols in its C2 communication. Other than the traditional HTTP 1.1, it also supports HTTP 2 as well as HTTP 3, also known as the QUIC protocol. So far, the HTTP 2 plus the HTTP 3 have around more than 70% of the usage among all the web servers. So I think it's a good idea to check if our security control have visibility about these modern protocols. For the profile flexibility, it supports some basic configurations such as the callback URL as well as the user agent. For user agent, we probably don't want to use the default one to go callback since probably the agent is too outdated, and we like to keep up with the version like the modern browsers using. And another feature I like is the JAWS3 randomization. JAWS3 is a fingerprint technique that fingerprinting the TLS during the TLS handshaking. In that handshaking, client will tell the server what kind of CipherSuite protocol CipherSuite it supports. And by randomizing that supported order, for example, the Merlin or those that can randomize the JAWS3 signature could further mess up with the security control. In our lab testing, once we have that JAWS3 fingerprint randomized, we could have around 3,000 different signatures, which is not manageable for the security controls. But then a newer technique called the JAWS4 to the rescue, which further sort the CipherSuite supported before creating signatures. With JAWS4 fingerprinting, those 3,000 signatures can be converged to only 6 signatures, which is more reasonable for the security controls. This is the callback screen of Merlin. They all look pretty similar. If we further take a look at the packet traces from the Merlin, we can see that there's some very steady area, like we highlighted in this picture. By further decoded with base64, we can see that there's some web token key value pairs, which might be an variable index to the detection. In short, since it's written in Go language, so the implant can be easily created to support different major operating systems. And the best part is it supports H2 and H3 protocol that could further test if our security control can catch up with these new attack vectors. The drawback is still some static pattern can be observed, which might be feasible to detect its C2 activities. Number 3 is Sliver. Sliver is getting popular in recent years by the threat actors, and it could also be used as an alternative tools to maybe somehow replace some commercial grade level C2 products. The C2 protocols it supports contains a lot, and one of the protocol is called the MTLS, or the mutual TLS, which is a little different from the traditional TLS. In mutual TLS, the client and server both authenticate to themselves, which is a better way to further protect the data in transit from the man-in-the-middle attack or data inspections. Another feature I'd like to highlight is the pivoting. For most of the C2 tools, they usually support the SOX5 proxy that allows us to use the compromised machine as a jump host to further let us jump into the firewall environment or to a different subnet that's highly protected. And with further adding TCP forwarding and reversing features that could allow us to further route the traffic from the internal network to the victim machine, or vice versa, from the attacker's machine to the external victim networks. Here's what the code looks like. Again, we'd like to take a look at the packet trace of the sliver traffic. In this screen, we can see that there's an area that shows there are 100 capital letters in the request body, which is by checking the source code, you can see that it's actually randomly selected from a list of 512 elements. So these words, the index of these words can be further converted to some binary information in further C2 communications. But anyway, since it's a feature that could further trace the C2 activity, it could further be used as an indicator. So by further combining the returned status code, which is quite rare, that's 202 accepted, we can further write some detection guidance with Ricada or Snow format. So we can first write a signature that's looking for 100 capital letters. And once those conditions be met, we could set a flow bit or set a flag. We call it the sliver C2. And in another rule, we could further check if that special flag has been set or not. If that's been set and the status code is 202 with content length 0, we could say that we might have a strong indicator that some sliver C2 might be running on the way. So sliver is getting popular among threat actors like APT29 and it's exotic lately, and plus it's high variety of these C2 protocols supported, which make it a great choice for testing things out. For me, yeah, sliver is one of my favorite tools in my simulation arsenals. Number 4, Mythic. Mythic is actually a framework like the Metasploit. It supports a lot of features, such as a lot of modules. Let's take a look at the web GUI. On the left-hand side, we can see that we installed a few payloads, such as Apollo, Medusa, Athena. Each payload is a different C2 implementation. Taking Apollo, for example, it supports only Windows. And for Medusa, it creates C2 payload written in Python language. And on the right-hand side are the C2 profiles it supported. We cannot mix the payload and C2 profile arbitrarily. Taking WebSocket, for example, it only supports for Athena and Freya. So in the following slides, we'll be taking take a look at the Athena over the WebSocket. The C2 callback, that shows some agent type that connected back to the C2 server. And if you're in a red team exercise that need to collaborate with team members, the feature it provided is called the MITRE ATT&CK mapping, which maps the commands or post-application activities you use on the compromised machine to further create some more meaningful TTP information based on the MITRE techniques. The Athena over the WebSocket we earlier talked about, it used the WebSocket by observing that there's a HTTP 101 switching protocol. The server will further, the whole connection will become a WebSocket protocol. So once it's upgraded to the WebSocket protocol, the overhead of the repeated HTTP header is gone. So in this web flow, we don't see any redundant HTTP headers anymore, which makes it more efficient for the latency or time-sensitive applications such as messaging or large gaming, online games. In short, the high support of MIT6 make it quite special tools for the red teams, plus the support of MITRE ATT&CK mapping, which make it a relatively competitive options for the adversary simulations. Number 5, Boretto. Other than the tools we earlier talked about, they're all open source free tools. But for Boretto, it's a commercial product earlier developed by Chetan Nayak. And the protocol it supports is quite a lot. But I would like to focus on the DOH later, since the DOH means the DNS over HTTP. We'll take a look at the topology later. Again, it also supports MITRE ATT&CK mapping, which might make red team operations more convenient. The look back, the callback looks pretty, since there are some GUI applications out there. For the DOH topology, it's a little different from traditional DNS resolution. In DOH topology, there's a server, a public famous server stands in the middle. So when the client trying to resolve an FQDN, example.com, like the diagram shows, the stage 1 and stage A now becomes the HTTP protocol instead of the traditional DNS protocol that talks over UDP 53, which might break some inspection of security controls from the enterprise. So if some security control that specifically look at the DNS for suspicious activities, this might break their inspection. Here's a test that we have the DOH implement traffic visualized. With that configuration, we set up a few OpenDNS protocols. So from the diagram, we can see that the packet size fluctuated accordingly. And based on the sleep time and the jitter time we configured, the communication frequency also changes based on our settings. For Bootretto, DOH, I think it's quite rarely supported as of the writing of these slides. But later on, I discovered that Corpus Drive also supports DOH in early March, I think. And like Corpus Drive, Bootretto also supports a highly configurable C2 profile. We call it the malleable C2. We'll talk about the malleable C2 later in different tools. And since Corpus Drive's been heavily pirated by the threat actors, recently there's some takedown of the Corpus Drive infrastructure, so which might make the Bootretto getting more momentum by the threat actors as an alternative to the Corpus Drive. Number 6, Dropbox C2C. Unlike the traditional command and control infrastructure that the attacker need to create the infrastructure by its own, there's a different kind of C2 that leverages the legitimate cloud service or any service that's available for the users. Let's take a look at the Left-Out-Loud C2 first, which is not a C2, but it's a collection of C2 framework, which could be further abused in command and control environment. We can see that the category is quite spanning different categories, such as gaming, messaging, storage, as well as the office productivity and even AI utilities. The advantage of using cloud-based C2 is that the infrastructure is out there already by the legitimate service providers. So the attackers can just focus on communicate to that service, and the client side could pull the stuff out from the service to check if there's any new command to run. And furthermore, since the service providers have the FQDN used by those services are highly trusted by security controls, so they have a high accessibility among the victim users. So we don't need to worry about if your C2 activity might be blocked somehow. I don't think that organizations will block YouTube.com, for example. But one of the drawbacks is that for cloud-based C2, the attacker needs to put the API key somewhere, either hard-code it or put it somewhere to retrieve. If the amount of victims getting higher and higher, there's a problem that the API token bind to that user might exceed the defined API rate limit. So this could raise some alarms for the service provider to take actions. Once that's been observed, the service provider might take actions and interrupt the whole C2 operation. if we take a look at a 10-minute time window of the Dropbox C2, we can see that there's a very specific patterns calling some special API endpoints, such as the list folder and download. These two endpoints has been called quite frequently. And for the C2 data that's being used during the communication, it highly depends on the cloud service we're using. For example, if like this one, Dropbox is a storage-based service, the data stored on it could be file-based. For example, there's some image file that could store encoded QR code, or even 1 second video file showing a QR code for the data for the C2 data communication. In short, cloud-based C2 is basically based on the service API abuse, so it's pretty easy to be observed if we got too many victims calling the APIs. Even it has great accessibility and availabilities. Okay, 2 more to go. The SourcePath C2 is a tool I developed a year or 2 ago to demonstrate that by abusing the TCP side channel could reach the effort of command and control or even data exfiltration. It's inspired by a technique called the port knocking in the MITRE attack. Port knocking is, the idea of port knocking is that from the server side, they're running the port knock server, which have specifically defined some correct sequence to match. When a client, like the client 1, sends new connection to the destination port toward the server with a very specific order to 5,000, 7,000, and 4,000. If that matches the sequence defined on the server side, the server will open a special protected port, say A80 port for the client 1 to access. But for the rest of the world, like client 2, the port 80 still remain closed to it. So by taking this concept to a different level, instead of using the destination port, I use the source port instead as a media to transfer the data. So by using the formula above, we can secretly exfiltrate some bytes over this kind of media. On the far right hand, we can see that it's a packet dump of some very normal web traffic. It keeps checking some kind of software version, looking for new updates maybe. But underneath, there's something shady going on that exfiltrates special data to the value of the source port. SourcePath C2 has been open sourced on GitHub, so if you're interested, you could take a look at it. It's a simple PLC code. And for more detail, I have a presentation in 2003 at BSides SG, Singapore, talking about that specific tool. One of the drawbacks of this technique is that we need to use the source port as the media to transfer data. So we need very high frequency of new connections, which might raise suspicions among security controls that have maybe layer 4 or layer 3 visibilities. And the last but not least, the Cobalt Strike. Cobalt Strike is one of the most famous red team simulation tools out there. It's so popular that a lot of threat actors try to crack it or pirate it. The most impressive design of Cobalt Strike is the Medieval C2, which allows us to further define how is the C2 traffic looks like. So we can further blend in our C2 communication in a very legitimate looking traffic. It also uses beautiful GUI to communicate to the team server. For Medieval C2, there's a lot of examples out there on the GitHub. I think it's more than 100 samples. So if we're not familiar with the format, we can just download one sample and tune it a little bit. Taking the one we highlighted here, if we use that profile as in our C2 traffic, it will make our C2 traffic look like someone is browsing the Wikipedia. So the powerful Medieval C2 make detection even harder or challenging for security vendors or have very effective detection. If we put all this together in the form, we can have a comparison table. And I would like to elaborate a little more about those highlighted. In Metasploit, it supports more than 30 executables, so definitely it wins the crown. For Merlin, even it doesn't have a lot of stars. I would like to shout out to the author, Mr. Russell Ventile. I like the way he supports modern HTTP protocols as well as support the randomization of JAWS3 to mess up with the security controls. And finally, making C2 traffic blend into the legitimate network is the key so far. So for Bootrattle and Cobalt Strike, that supports highly configurable C2 profile. It wins the full 5 stars. So by knowing all this information, we could have some kind of remediation. Other than deploying these static signatures, we could also focus on detecting the anomalies between different protocol activities, such as DNS protocols. We could further build up some kind of user baseline to see if some user now is visiting some weird, unknown, or bursting domain that no one's been visiting before in your organization. And we could also further utilize additional fingerprinting techniques like JAW4, which might be the hero to the rescue to counter the JAW3 randomizations. So in short term, I think it's pretty obvious for us that we could use the IPS signatures to detect those static patterns from those known C2 patterns. And we could also block known malicious IP or domains from the open threat intels. And furthermore, I think it's pretty useful that we could further restrict the user from accessing unknown DNS servers, since I think it's pretty manageable. The InfoSec or IT come up with some kind of trusted DNS list, maybe 3 or 5 will do. Yes, in that way, at least we could mitigate some kind of unknown DNS traffic that's been abusing for C2. For long-term suggestions, since in this modern world, almost maybe 99% of the traffic is being talking to over the TLS, which is encrypted. So I think we might need some solutions to further inspect those traffic to have more visibility on what's going on. And with a more advanced detection using heuristic or even machine learning protocol, machine learning way, we could further extract the features we earlier talked about to see if there's something we could use as a baseline, as a basic set, and then based on some malicious, intentionally generated malicious traffic to see if our detection can work or not. And for those companies or organizations that have resources to conduct red teaming or adversary simulation exercises, I would suggest the red teamers could spend some time to pick maybe at least a tool or two to further try those tools out. Not necessarily to talk at the tools we talked about, maybe some random C2 tools you're interested in to see how your organizations or blue team can handle or not. So in this highly interconnected world, everything is even connected more than ever. I think it's pretty important to know what tools the adversary or threat actors might use and know these tools' behavior. And based on what we've learned, we can further hopefully find out if there's new gap or not, to further come up with more complete, even defensive or offensive strategies. Thank you.